on, please, if you don't have it. Okay, so Oded Margalit from IBM, I mentioned before. So many things to say about you that I don't say anything.
Okay. That's a good question. Thank you for inviting me here and for the very exhilarating conference. What I did is wrote a few slides trying to summarize things we heard today. So first of all, I think one of the topics was brain research, and there are three reasons to try to understand how the brain works. The first one is my favorite, basic science. Climb the mountain because it's there, just understand how the brain works, and some of the talks we heard today were very interesting in understanding how the auditory system and other systems of the brain function.
You don't mind putting the microphone on?
Oh, okay. Is it better now? Okay. The second reason is we try to borrow ideas from the brain. If something in the brain is working after millions of years of evolution, then maybe we can mimic it in our computer programs and try to do the same. So this is another reason to understand it. It's not always we can assume that the humans or animals perform things in the optimal way. For example, we are moving using wheels, and almost nothing in the nature uses this kind of transportation, and we think it's superior. But sometimes it's interesting to understand it. And the third reason is BMI, brain-machine interface. Even if we don't care how the brain works, even if we think that we have wheels that are better than the legs and we don't need to borrow ideas, we still have to face the fact that the output of everything we do is consumed by humans, so we better understand what the cognitive system that is reading our output is doing in order to give something useful. This slide, this is the main slide, is comparing the brain to the computer in several aspects. The first one, the brain is limited capacity, fixed for centuries. The CPU, the I/O, all the interfaces are quite the same, while computers are following Moore's law for decades and are exponentially growing with faster CPU. We have scaling problems. We have all kinds of interesting problems because the environment changes. Another interesting thing that was raised here several times was the difference between the bottom-up and the top-down. What computers are doing, they are taking analog signal A to D, transfer it to pixels, run the pixels into all kinds of shifts and other operators, try to build segmentation and concepts, and at the end they try to see if this is a face or a cow, two-legged or four-legged or anything. While the brain probably does the things the other way around. First we immediately recognize what we are seeing, and then we are starting to...
No, that's the same.
You have
neurons.
Your neurons are like your pixels or whatever.
What? The two, there's not a contrast. It's the same.
I mean recognition. Here, when I see a picture of a cow, the word cow comes at the left side, hand side at the end. The end of the process is understanding that I'm watching a cow, while humans first understand that it's a cow, and only later...
Well, we have both processes. I mean, Merav is not here. Well, actually, responsible for this notion of what we call reverse hierarchy, which means that we have both bottom-up and top-down processes together. The way I like to think about it is that the brain is making a prediction or hypothesis about what's there, then testing. Hypothesis testing is a lot more efficient than generative models. So essentially, we guess there is a face, and then let's verify. We guess there is a cow, let's verify what we need to see. We guess, we always make predictions. I'll come back to this tomorrow again, but so it's really not recognition. Implementation is hypothesis generation, and then hypothesis testing, and the hypothesis generation is based on path and pixels and feature. It's a bottom-up approach to some extent.
That's why, for example,
and it draws in time. That's really the key.
Yes, I accept it. That's why, for example, understanding video is much easier than understanding still images, click for humans.
Gives you an additional dimension.
We have a very good associative memory. We can recall things after many years, and sometimes it's corrupted or compressed, but we can recall it. While we heard today a few ideas about video indexing, how to do it. It's a direction, but still I think humans are superior, at least now in this direction category. When you have a big enough hammer, everything looks like a nail. So the brain, most of it, a big part of it is devoted to image processing. So we convert everything to image. Even ultrasound, which is actually kind of sound, we are feeling more convenient to view it as a picture. When we translate things to pictures, we understand them better. While computers still understand things better when translated to text. That's why, for example, bag of words, trying to take concepts from the pixel and translating them to words, and this is a problem that we already solved. So computers feel more convenient in words, textual environment, while human in...
I must comment on this. I mean, this is something that's bugging me since Shmuel's talk. I mean, essentially what we call understanding is, at least where I come from, is the ability to describe it in words, to tell a story. And telling a story is a sequential process. I mean, there's a beginning, there's a middle, and there's an end, and some conclusion. What Shmuel did to video was essentially scramble the story, but isolate.
That's called bag of words, right?
Yes.
Bag
of words is scrambled.
Bag of words, you special in bag of words.
No, much better bag of words. So I wonder if what you mean here by translate things to text is really keeping the narrative or the story of the image there in a way which is, or you leave it to the humans eventually.
I disagree with you, Tali. I don't think
that's why you're
understanding is necessarily a sequential process. If you look at an image, you as a human look at an image, you don't describe it pixel by pixel. You get a total impression.
No, so
story.
I know that there's a big and long argument here between the image processing people and the audio processing people like me.
Actually, if you look at eye
who are
movement,
coming from the notion of language.
if you record eye movements of people looking at an image, they jump all over the place. It's not a sequential process at all.
No, but eventually what we call understanding is the story. I can describe to you what's happening there.
Understanding
this is a sequence of items.
I think the difference is when you recognize as a person what you see in the picture, and when you want to translate it or to describe it to someone, then you have to move through the
But
text.
I don't think this is how we understand.
No,
I think that's
of
very
course.
inferior mode
Okay,
of
so
understanding.
No, I disagree with you on the nature of text as relative to understanding. If I want to describe one unique phenomenon, there are in the English language several sequences of words I can utter to transpose to you the same understanding. I can put the cow in the first.
Uniquely defined.
So time is not essential as it is as strict as you defined it just moments ago. It is the association of several words together which will bring to you the understanding. And that is exactly the same as what's happening when viewing at a certain picture.
No, so it's not black and white.
No.
But I'm convinced that our was taught, there is a line of thinking that we do very little parallel processing. We move from one thing to the other in our consciousness. I mean,
So you think
we're essentially one-dimensional.
You think that because language is sequential,
sequential, there's no question about it.
Language is sequential.
No, the question whether we know to understand within language, or we have some other processing of video or images which is distributed in parallel and has no sequence in final. So I think to some extent it's true, but the long story eventually should be sequential.
No, we live on time. We have a time axis
to
in
be
our
very
life.
fundamental, and we'll come again. I'll come back to this in my talk tomorrow. The notion of prediction and why prediction is so essential in order to model things. But prediction is a temporal process. But on the other hand, I completely agree that there are different views here. And, that's why we're here. I just want to somehow sharpen this difference because so the difference between text and images, in my view, is really the nature.
I agree with you about the importance of prediction, but I don't think it's a temporal process.
Okay.
I'll also talk about that.
We'll talk about it tomorrow. Let's come tomorrow if you want.
For example, face recognition. When you see somebody you recognize, then you retrieve his picture from your memory, and you even compare it. If, for example, the new eyeglasses, you recognize it by comparing it, but you don't necessarily recall the exact second you first saw him.
No, it's not absolute time. It's always relative time. I would argue that time is an entirely subjective thing, but the sequence is very important. I mean, as far as I'm concerned, I mean, what comes first. Yeah. But and also, I found it quite incredible actually that the image processing and the video processing people went back to some sort of discrete, in a finite number of entities, which they call words or concepts or objects, and eventually really moved this high-dimensional problem into something which looks much more like a language again. And as far as I'm
yes,
concerned,
but I think this is because of our tradition to use words and to use
because
languages.
our
And
mental
also in
processes
computation
are
because of
symbolic.
database, because we are used to describe the word with words or with label or with something else. But I'm not so sure that we should necessarily translate everything in words.
No,
this is just only.
I definitely I want to raise an argument.
Uh-huh.
It's trying to be a little bit provocative.
Yeah, yes.
But I really think it's interesting that, in a sense, you all move to some sort of language-like description, but bag of words, narrative, story, whatever it is. Whether you like it or not, that's what we have today.
We don't all do that.
I have two comments on it. One is if you take, for example, speech and reverse it backward in time, you still can recognize the language, even the speaker, but you of course can't recognize the content. And the other is that also in speech we use the SfP, which actually throw away a lot of the unrelevant phase, for example.
Just to, you have to remember the time order of thing in vision. We have for 20, 30 years trying to do without words.
Yes.
The reason visual work is so popular because it works.
That really is.
Absolutely.
But I
there's
think
a good
it's
reason for that.
No, but I also
I
think
agree.
it has
I
its
always had
limitations. I think it was something that works that far, okay, and beyond that you have to go to non-discrete things and non-parametric things. I completely agree with you.
If
question is again, what do we mean by
that is not
understanding, describing?
as the discussion goes,
Yeah.
I now have I kept it silent, but it's not translate to text, but translate to a set of concepts.
Yeah.
And by all means, that also in your paper, if you do not fixed assignment to concepts, but a soft assignment to neighboring concepts, you will improve.
Mm-hmm.
So the concept is only a stepping stone in order to make things manageable.
Yeah.
But basically, so if you do soft assignment, it works better.
I completely agree with that.
So-
We do soft assignment all over the place.
Yeah. So that tells you that yes, it's useful to use concepts. Concepts are unorderable in a sense, and surely in vision they are unordered for the moment. They have neighbors, but they have not a metric which spans all over the place. And the same holds. And so text is not as precise as it
binary reduction. It's taking the
It is a
millions of
dimension
bits
reduction,
into
yes.
something smaller. You can call it words in text or concepts.
Yes.
But if I may also add something, we humans do it, you see it, we like to discretize things, perception discretize things, like in colors. That's an example. Why do we put this border beside the red, and there's a lot of little colors there? So
Because
there
to
is
simplify
something,
the process is true, yeah.
This is,
oh, there's something computational
brown
here,
cow,
just
which is an excellent
computationally
Yes.
tractable,
And observable, otherwise,
observable, and in an
if
implicit
it's not
way.
observable,
The
it's
fact
not
that it
valid.
works for vision or for video may hint that this stuff people were confronting them in the course of the revolution and led them to find similar solution. I mean, it is little it needs a lot of support from needs much more perspective on that fact, but it could be supportive in this direction.
And of course, you're using my first point here, the hardware.
Yeah.
You're optimizing the algorithm given the hardware, and you're changing the hardware in a much, much longer time scale. It takes centuries to change the hardware and take seconds to change the software.
Although it could be a property that is independent in the hardware in many things, but it's the fact that the mere fact that we want to discretize or to reduce the dimensionality and creating this vague or soft or sharp concept, it may be very interesting property because of how the way, I mean, if it really works for real time, for real problems, it might be some kind of architectural basis of perception.
It would be very hard to demonstrate that.
I mean, the demonstration, proof of it is in the pudding. I mean, whether it works or not, or whether it corresponds to what our brain does, which you don't quite understand. But the fact, we've been through this discussion with Safra, for example, many years ago, and I just find it interesting that eventually the machine, the computer vision community is moving to some sort of symbolized representations, and this seems to help them doing what they wanted to do, which is image understanding or video understanding. So I'm not. I just want to comment and to think that this is interesting. That's it. In this comparison, it's not really computer and brain, it's something else.
The next point is the way we learn. Humans learn by recognizing regularity and then finding what's new and what's novel. Not only human, but also rats, as we heard, can recognize tones that are surprisingly different than the tones that they usually hear. I can't resist to show you one of the Ig Nobel prizes for making locusts hear the music of Star Wars and detecting their brains. So it has potential. And in computers, the problem with computers that they never do what you want them to do, but rather what you tell them to do. And the problem is it's not always the same. We use supervised training, tell them this input should give you this output, build the model, give them the set of modules and find the best one in this set. We try to do it unsupervised, anomaly detection, but still the main paradigm here is that human work from just observing the input and learning without almost any prior model of the world, and computers are coming from the other way of doing very fast things that they are programmed to do. So, for example, if I'll ask you to multiply 813 times 1, 2, 3. And computers can compute this multiplication very easily. It's multiplying two 3-digit numbers. Humans will do it slower, but will gain one more insight after doing it. What's the approximate product? thousands, it's actually 9,900, 999. And humans see this value as interesting, while computers see it as any other random set of bits when you are.
Well, I wonder, computers don't see anything, but I can easily teach them to see this as interesting.
Yes, but then they want to see other things as well. Okay. I think it's the last point here. Our memory is working, I added 2 quotation marks to open a discussion here. Do we really preserve the causality when we summarize our memories? Causality, when we summarize our memory, not only video. And the nice talk we heard is that when we conserve only the local, very local time and space, do it very rigidly. We don't stretch the car in time, we don't squeeze it in space, we keep it exactly as it was, but we move it into a different time, we overlap several things together, and the results seems very impressive. 24 hours of information, it looks like all the relevant information was put into this 20 seconds. We know, for example, in the airports, airplanes are taking off and landing, cars are moving, and you want to be able to see it in a fast-forward version of running it 500 times X. You see only blips of you would see the shadow or the sun movement in this picture. I guess it would be the only thing that will remain. So this is actually a point I wrote here because it generated a lot of discussions wider than maybe we can talk about it a little more here. First of all, the 2 question marks. Do we really, is the human brain, does it or not?
Memory of events.
Yes. How
maybe
do
we tell a story which is not necessarily true. So we compress, at least I compress the events by essentially linking them in some sort of a narrative. That is exactly what I did before. This is how my memory works.
And the narrative
maybe the fast memory works in video, I don't know, but I don't see pictures. I hear a story.
You inside the stream.
So my memory works by
stream. So he's conserving the object, so he's the same as conserving the stream. As long as it's not harming the sequence inside an object, what he calls an object is the same as you call an object.
Unless there are interaction between them.
You don't conserve the temporal sequence between streams.
In my memory, you mean?
Yes, in your memory. You also in memory of the temporal.
I distort time completely, but I think I preserve the
inside the stream or inside an object.
Okay,
for example,
I'm asking.
Suppose you were sitting in this corner that the picture was taken, the movie was taken, and watching it for a full day, and then telling us the story. The story would be a lot of cars went in all directions, but you wouldn't remember that the car that turned left was after or before the car.
No. So obviously, if it was not important, I will not remember. But that's why I think that another layer on top of this.
So when there are clear causality,
to identify
you remember.
really
but like,
important and novel
if
events.
there is an accident,
and then I want the order.
the car came and they collided, that you remember that it occurred simultaneously, right? Otherwise they would have collided.
If I hear a shot and I see a man falling, I would like to know the order in time.
I think that our brain do a sort of summarization, but by sensation, by emotion, by many things, not only temporal. So it's semantic summarization of what is important for you. Sometimes, for instance, I remember that I was in one place in the world, but I don't remember if when I was there, or maybe it was before or after an event. When you have to describe something for a purposive situation, maybe you need time. But just only to remember to do association and to recognize, maybe it's not necessary. Time is just only one of the variables possible.
I think it's more important than other variables, but you can ignore it to some extent in some short period. But obviously, in this sequence, you really need to know if the car is moving in that direction or that direction, or if there's still causality, local causality, even in the videos of Shmuel.
And sometimes, for example, a very primitive sense is the smell. sometimes you are connecting things to a smell, regardless of the time.
I think there are two different issues here. One is whether this represents the way we memorize things and so on, which it probably is not. But there's another issue, whether this is a useful representation.
No, it's
I think it's
absolutely
extremely useful.
But it's useful because our brain complements it somehow.
No, it's useful not for visualization necessarily. It's useful for indexing. Because if somebody stole your car and you don't know when during the day it happened, and all you can do is fast forward through the 8 hours of video, by the time you find when it happened and who took it, the guy will be 2 hours away from
absolutely
you.
no argument.
Whereas if you look at this thing, you immediately spot the stolen car, you click on it, it brings you to the appropriate place in the video, and you immediately see who took it. Within 10 minutes you'll catch him. And that's got nothing to do with the way we memorize things and so on.
I completely agree. I have absolutely no doubt in that the whole thing is extremely useful. I'm trying to see if we can, first of all, learn something about the brain from that. Maybe it's not what you want to do, what I want to do. And second, what is still missing, or how can we improve it? And I think what would be very nice is not only to compress it in time, but to label it according to some sort of relevance, saliency, causality. I think that the causal summary is extremely important. What is reserved there now maybe is mostly what I would call local causality. It's local in time. On short periods, the video causality is preserved. The question is how to go beyond that. I'm not saying.
Causality and basically can tie causality across objects. Then
that's one of the challenges. That's why we call it challenges. I think it's an interesting challenge, and it's not necessarily unimportant.
I have to take Kali's side, even though I, of course, like this work a lot, but there is lots of things that we miss that you don't see in an airport scene. So, for example, if there will be a robber who is running behind after somebody, we would put something in between that you never see the connection between the robber and the person who is running from you or chasing.
If the robber is the only one running, then you would see it.
You have two people running, and then
you have two people running, one chasing the other, okay? In the summary, they can be placed in completely different times.
Running together.
Of course it has its limitations.
Another problem is that maybe both of them, the brain surely, the computer, I don't know if I'm still able to do, we should connect concept, event, and everything in a sequential manner, but in many dimensions. So not all in temporal dimension, or not all in color dimension, but we need to have a representation that put together different dimensions. So I absolutely don't know how the brain can do this kind of things, but I know that it's very hard to do with computers.
We need a hierarchy, and the hierarchy should be both on the object and on time as well. So I would like a summarization like this, which really, as I said, what we do now is mostly local causality. On order of several pixels and several seconds, things look causal, but not globally. A sequence of things that I would like to link, so a summary should not be one video, but somehow a hierarchy of videos. And just like all the other hierarchical schemes. Actually, I was hoping that Rob was into this, because this is a major part of her work, is this hierarchical thing, and I think it's a major part of our mission. We group things in different layers, and hierarchy should work both on the temporal domain and on the space domain, and we're just beginning to do it. Anyway, go ahead. I'm exhausting the patient.
The next, maybe a middle step between full hierarchy and just tracking a single object would be to track pairs of objects. For example, we talked on one of the breaks, Shmuel's system wouldn't detect a case where a car is crossing in a red light, because it's supposed to have traffic lights there. He would track the changing light of red, green, yellow, and track the moving cars, but the fact that cars never or always never move across the intersection when the traffic light is red is something to do with pairs of objects. So maybe of course the complexity becomes much higher. It's quadratic to.
This is something that I call learning the normality. So learning that normally the car goes through when there is green. Maybe it's not very easy because there is not abnormality in this. Yes.
We should simply have
But I
different
live in the
models.
north of Italy, so
Okay,
it's
this is the last slide, just a few other questions or comments. First of all, one thing that was common to almost all the talks today, we have huge amount of input, video streams, 1 million, 10 million hours per year, Dutch television, video surveillance, all kinds of input, but most of it is write only. 96% of the data is never being watched, and of course this let us.
Much of it is not even being written. It's just being recorded and thrown away. No,
Yes,
I'm serious.
there
If you
are.
don't watch it online, you'll never see it.
Yes, there are.
It's right only to this, which are
About-
erased the next day or something.
It's not even erased. It's just recorded for viewing, and then it's not even recorded. It's not saved anywhere.
But most of
The amount of information that travels in the world is around 1 zettabyte. This is 1,000 exa, 1 million petabytes, and the storage is much smaller than that. So you can't keep record of the zettabytes that are transmitted each year. Half zettabytes, 2 zettabytes, it's growing, of course. So I agree. Sometimes it's not even write only. It's pass through to for example, detecting the U-turn, and I think very very interesting. Any work that finds the interesting parts in huge amount of information, and of course we have a lot of information and we have much more. So this is another thing is talked about it earlier. There are two ways to solve a problem. One is modular. Separate it into different parts and solve each one of them separately. For example, we have a world, we want to get a picture, a bit. So we take a camera or a sensor. The role of the sensor is to get some input from the world and put some bits out. And the best sensor is a sensor which captures the world most accurately and then finishes its job, and all the rest is done by other parts. So A to B, analog to digital, text to pixel, and then we take the pixels and try to build objects and segmentations and find activity, etc. Many works, especially in the modular model, are concentrating on a single arrow. Just we solve a single problem. What's the best camera we can build? What's the best denoising algorithm we can do? What's the best, I don't know. And the holistic approach is trying to look at the problem as a whole problem, and then soft decisions, for example, helps you a lot. When you, instead of taking the picture as good as you can take it, and then moving the results, take it less accurate, but be prepared to answer questions or to convey the uncertainty that you have in the picture to the next layer. Doing it in the holistic way always gives better results, but in expense of being much more complex system. So
isn't it again the bottom up top down dilemma?
It's not only it relates to it, but it's not only that. The modularity paradigm says that you solve each problem separately. If you want to read what is written, then first take the pixels, then take some features of the pixels, then run the best learning algorithm from the pixel to do the OCR and get the letters. The holistic approach says you have the paper, now you want the digits, and you can sew all these arrows together instead of doing it one by one. This is probably the last item say. There are a lot of usages that all the things we talked about can be used in. We can track the ball in a soccer game, it's entertainment or sport. We can track people in a mall and have some commercial applications. Of course, the security is the first application, although it sometimes can create some privacy issues. In medicine, image processing can be very useful to detect anomalies in breast cancer, for example, and the thing that wasn't covered, at least just a single word in one of the talks, art. If we put, instead of understanding what's going on, try to build generative models, then we can create art. We can learn what is nice, interesting, and beautiful, try to compose things.
Actually, art can be made also by analysis and then synthesis. You take and reshape or regroup an image or whatever. Actually, part of what Shmuel showed us was art as well.
The 20-second summarization is
So, but if you look for money, the order is probably different.
No, I think this is the
order
of money.
This
This is the order of money.
Okay.
But really, medicine, you should put also.
Homeland security changing before or after 9/11.
Legal issues.
Maybe. So this is the right order.
I think entertainment is on top.
The best 3D modeling hardware were actually first used in fine sense in the entertainment.
All right, thank you very much, Oded. I just want to encourage you not to think about it as a conclusion, but as just a commercial advertisement for tomorrow, which is supposed to be more or less some shift towards the machine learning, but Michal and Yair and a few others will keep the video vision image processing dilemma or debate between the two communities. And if there are people who are not running to Tel Aviv or forward, I don't know where, we have dinner at 7. If anybody needs a ride to Tel Aviv,